Hi everyone, welcome to a brand new chapter. We're going to talk about radical expressions, radical equations, roots. So basically radicals mean you're dealing with those square root boxes. And sometimes they're easy and sometimes they can be really confusing. So let's start with this first section. Just review some basics that are kind of important for us in simplifying roots or radicals and what all the different parts mean. Just gets a good foundation. So we're going to start off with just a review of what powers are, because roots are the opposite or the inverse of powers. For instance, 5 squared is 25. So if I want to do this backwards and I want to say the square root of 25, then that would be 5. So I'm taking this and its square root would be 5. Or 5 to the power of 3 is 125. So the cube root of 125, and we're going to go over this, that's how you do the cube root. The cube root of 125 is 5, right? This is 5. Or 5 to the power of 4 is 625. So the fourth root of 625, you guys are getting the idea, right? The fourth root of 625 is 5, which means what number multiplied by itself 4 times equals 625. That's what a fourth root means. So that's the basis for what we are doing in this section. Okay, this number right here is called the index. If an index is odd, it's an odd number, like this 3 or like this 5, then you're only going to have one real root. That's possible. And I'm talking about negatives or positives, just one. If this this index is even, and this one is even, we don't write the 2 for a square root. Everybody knows that that's a 2, so we don't bother to write it. But this one's even, 2, 4, 6. Then there are 2 real roots of the answer. But the positive one is the principal root. That's what we're going to focus on, is the principal root. You could also have its opposite, which would be the negative. If this is odd, there's one real root, whether the number inside the root box is positive or negative. It doesn't matter. There's still going to be one answer. But if it's an even index and this number is negative, you're not going to have a real root. It will be an imaginary root, right? Not a real one. So just bear that in mind. We're just going to deal with real roots right off the bat. We're not going to deal with imaginary ones. Some vocabulary would be helpful at this point. When we see this kind of root box, which is called the radical sign, now we know we're dealing with radicals. So this is the radical sign. This number out in front is the index, which I already said. And then the number inside is called the radicand. So if I refer to the index, or if I say, do you have a radical? I'm talking about this. And the number that is being reduced or whatever, this number inside, is the radicand. Okay, some of the thing that you're going to do is being asked to just give some numbers and what are the cube roots, the real cube roots of these numbers. So that would be, it would have an index of 3, and these numbers would be the radicands. Your calculator can do this for you. Some of them you can do on your own. So this means what number times itself 3 times is 0.008, and 2 to the third power is 8, and we have 3 decimal places. So the answer to this one is 0.2. And that multiplied by itself 3 times is 0.008. This is the cube root of this. The cube root of negative 1,000, what number times itself 3 times? This one is negative 10. Negative 10 times negative 10 is positive 100, and positive 100 times negative 10 is negative 1,000. See, because this isn't cube roots or odd index, we can deal with negatives, no problem. And then the cube root of 1 over 27, cube root of 1 is 1, and the cube root of 27 is 3, so that's 1/3. When you have an odd index like 3, you're only going to have one real root. Okay, now we have some numbers and I want the fourth roots of these. Since 4 is even, we're going to have 2 different real roots of these numbers. All right, so the fourth root of 1 could be positive 1 or it could be negative 1 because negative 1 to the power of 4 is also 1. So this could be plus or minus 1. The fourth root of this is a negative number, so it has no real fourth root. This is 16 over 81. The fourth root of 16 is 2, and the fourth root of 81 is 3. So this is 2/3, but it also could be negative 2/3. So this could be positive or negative 2/3 because it's a fourth root, has 2 answers. Okay, one at a time, let's just try some of these. What would be the cube root of negative 8? What number times itself 3 times is negative 8? That is an odd index. Its answer is negative 2. What's the square root of 0.04? And that would be 0.2 because 0.2 times 0.2 would be 0.04. So this would be 0.2. Now you may think, wait a minute, why isn't it negative 0.2? Why did I only put positive? Because I didn't ask for all the roots. This, when you see it in a radical sign like this, they are only asking, this represents the positive roots, all right? So we're not going to write plus or minus in this case. If I ask for all the roots in a sentence, then yes. But if I have this in the radical, this represents the positive roots of 0.04, and that's why your answer would only be 0.2. All right, what is the fourth root of negative 1? This is even, this is negative. It has no real root, no real fourth root, so there is no real fourth root. Now this problem is interesting because we have negative 2 squared and we want the square root of that. And most of the time we would think automatically then the answer would be negative 2, but it's not. It's still 2. So negative 2 times negative 2 is 4. So this represents the square root of 4, which is 2. So I'm still looking for a positive root. This being a 2 and this being a 2 doesn't necessarily mean that my answer is going to be negative. I'm still looking for the positive root. That one's kind of tricky. All right, let's just do a self-check. Make sure you understand this really well. Here's 4 root problems, radical problems on the board for you to simplify. So simplify these, that's the way the instructions would be. And what would your answer be? So if you need to pause the video and try to make sure especially, how can I get my calculator to find these answers for me? That'd be great. And then unpause and I will tell you what the answers were. Okay, the cube root of this one, this should have been negative 3. So this simplified is negative 3. This has no real root because it is a negative and this is even. This is 7, not negative 7, because negative 7 squared is positive 49 and that's positive square root is 7. Be careful of that. And this has, again, no real root because it is negative. So that would be imaginary. So this one has no real root as well. So how did you guys do? Now, because of this situation, sometimes we're going to be dealing with variables in radicals. And when we have a variable like this in here and we're finding its root, there are times when we want to say, no, I don't want that negative. I want its absolute value. And there's going to be times when they really are going to insist that you put an absolute value symbol around those variables. And there's some certain conditions when you do that, and you'll really need it when you work on the computer. So in this next section, when we start dealing with variables, I'm going to try to explain to you when that will be. Okay, now we have a problem that involves a variable. So this is 16x to the power of 8, and we want to find its, or simplify it by finding its square root. So the square root of 16 is 4. That part's easy. But what would we do for the square root of x to the power of 8? So x to the power of 8 is x to the power of 4 times x to the power of 4, isn't it? So we have 2x to the power of 4ths. So 4 times 4 is 16, and x to the 4th times x to the 4th is x to the 8th. So this square root is 4, and this is x to the 4. And is there an easy way to figure out what that is? And there is an easy way to do it. So at least with these variables, this one is just the square root of 16. That's 4. Hopefully you have your perfect squares memorized. But when you're trying to simplify these variables, this is a method that I find works really well for me. I look at what my index is, and in a square root, it's 2. And I just take this power and I divide it by 2. So 8 divided by 2 is 4. So when I have two groups of 4 then, don't I, to make up this 8? So my answer is 4x to the 4th. Now when I have this even index, this might be a situation where I would need an absolute value because I want my positive answer and I don't want a negative, I want my positive. But anything to the power of 4 is always going to come out positive anyway, so I will not need my absolute value symbol here. It's just 4x to the 4th. So here's another problem. I want the cube root of a to the 6th, b to the 9th. I want this simplified. So remember what I said before. If I take this 6 and I divide it by 3, I will get 2. So there are two groups of 3 in 6. So this becomes a squared. I can take out 2 a's. Do you see that? Because 2 times 3 is 6. How many 3's are in 9? 3. So I can take out 3 b's. Take out b cubed, because b cubed to the power of 3 is b ninth. I'm going backwards. Multiplication is powers, division is roots. So 9 divided by 3 is 3. 6 divided by 3 is 2. 2 times 3 is 6. It's a power of a power, right? I'm undoing powers. 3 times 3 is 9. There's my answer. Now, this is an odd number. So if these roots are negative, it doesn't matter when you have an odd index. I don't care if they're negative or positive because there's only one real root and those negatives play out just like they want. So when this index is odd, I don't even need to think about an absolute value symbol on any of these variables. Okay, another example. I have x to the power of 8 and y to the power of 12, and I want to find the 4th root of that. So I'm going to do opposite. I'm going to divide again. So 8 divided by 4 is 2. So I'm going to have 2 x's, or x squared, because 2 times 4 is 8 to the power of a power. I undo that. 8 divided by 4 is 2. And then 12 divided by 4 is 3. So I have y to the power of 3. Now this is an even index. I want to make sure that I'm just dealing with my positive roots, because this means positive roots. If I don't want any negatives. If I have a negative number in here and it's raised to the power of 3, it'll end up being negative and that'll mess up everything. So here is an example when I want my absolute value symbol. So this is when you need it. When this index is even and the simplified version that comes out is odd, then you're going to need an absolute value to make sure that this stays positive and doesn't turn negative, because a negative times a negative times a negative would give us a negative answer. We don't want that. We only want the positive roots. Okay, so when the index is even and my root answer, my root that comes out is odd, I'm going to put absolute value symbols around it. Okay, so now that we've walked through some of those and looked at them one at a time, let's practice a couple. This one, the square root of 81x to the 4th, and that would be, what would that be? Pause it, figure it out. This would be 9x squared. Remember, the invisible index is 2. 4 divided by 2 is 2, so I have x squared. 2 x's pull out. That's one way I think of it. This is 9x squared. This is even, but so is this. I don't need an absolute value symbol. Okay, cube root of a to the 12th, b to the 15th. Pause that if you need to, and then check. Okay, so divide these by 3. 12 divided by 3 is 4, so that becomes a to the power of 4. And 15 divided by 3 is 5, so that's b to the power of 5, and that is this radical simplified, a to the 4th, b to the 5th. This index is odd, don't have to worry about absolute value symbol at all. This one is your lesson check. What's the 4th root of x to the 12th, y to the 16th? Do you need an absolute value symbol in that? So figure that out, bring that in for your lesson check for this section. Okay, so our last section or our last problem in this is a word problem. It says that some teachers will adjust raw scores when they give a test that is particularly difficult, and this is a formula that they use, which is pretty crazy if you ask me. So A stands for the adjusted score and R stands for the raw score. So in this case, if the teacher used this, it would be 10 times the square root of the raw score. What would be the adjusted scores for raw scores that ranged from 36 to 90? What would be the range of the adjusted scores? So these are the original raw scores. So you put them here in the radical box, and you find the square root of 36. That's 6, and 10 times 6, that brings this up to 60. That is crazy. So instead of a 36, this student passed with a 60. So for this score, you would find the square root of 90, which is 9.4868. So 9.4868. And if you multiplied that by 10, it would be 94.8 or about 95. So it would increase for both students. Not as much, significantly helps the lower scores a lot more than it helps the other scores, but it still helped both of them. So that's an example of using radical equations in a real life situation. So that's 6.1. That's our introduction to radicals. And if you have trouble figuring out how to use the radicals, find it in your calculator. I'll help you as much as I can in class. And then we'll go on from there in the next section. So bye for now.